Hi everyone, and welcome to this second video for the sprint of the HuggingFace Wav2Vec training, where everyone is kind of trying to train the Wav2Vec to feed the hub of HuggingFace. So today I'm gonna do my best to get the 3 videos I wanted to do. The first one is around systems. If your job is crashing, what's happening, and how to debug it, kind of. How to speed up your training and speed up the boot of your training. The third one, so the 2 first items I wanted to talk, and especially the cache. I'm going to talk a bit about the cache on the systems. The second video I wanted to have was around the feature I've added to the image, like new notebooks and few other stuffs like weight and bias. The third video I wanted to do was around data. Some people start to have some good results and want to download the data, download the models, and push it back to the HuggingFace hub. So we're gonna look into data transfer. So let's focus on the first video, which is around systems. As I explained before, the system is a bit specific. In a sense that it has a way to attach your bucket, object storage bucket, to the job. So how does it work? Basically, you can have an object storage bucket, what we call containers, and it's, for instance, the data one, and you might have some subfolders, and I suggest that you do have some subfolders, one subfolder per language, and maybe even a subfolder per training experiment. Like you want to change the batch size, you want to change the learning rate, you want to change, like, I don't know, many other things you can try, like the number of epochs or whatever. I suggest that you have some subfolder per experiment. It's going to be way easier to synchronize up and down. It's going to be faster for you and for the system. So and I would say that having a sub directory for each language is the mandatory one if you want this to kind of be fast enough. So let's say you want to attach this workspace. I also suggest that you have a data bucket if the data is big. For small languages, won't make sense. Like Turkish is pretty small, the dataset is pretty small. It's going to fit on the GPU by itself. So the GPU has kind of a dedicated storage to it, and it's pretty limited. It's around 16 gigabytes of local storage. Because you have a big network file storage under the hood. And what's happened is when you start a job and you attach a volume, it's going to bring the data on the NFS and attach this path of the NFS to the GPU machine, kind of. And so if you link 2 buckets, for instance, the other one, the output models /IT for Italian, it's going to bring the data there, or it's going to be empty, whatever. The job's going to run. The job's going to either write to data maybe, or maybe it's going to write to output models. I hope so. So you need to plug those 2 buckets in a read and write mode, okay? The second thing is going to happen when the job is done or died or whatever, stopped. The data is pushed back to the object storage, synced back. But there is a way that you can keep the data. So for instance, if you do some pre-processing for Italian, so you're going to have some data, for instance, for the Italian is going to unzip the data, is going to do some massive reprocessing on it, etc. You don't want to do that for each experiment. So what you're going to do, you're going to add a cache option to the data. So the data is going to stay there on the NFS, wait for another job to come. When the job comes and is attached the same bucket, the system is going to look at the difference, a bit like Git. It's going to look at the data there. It's going to look at the data there, find the difference, and then bring the missing pieces from the object storage onto the NFS. And this way, you won't have to do the reprocessing. You won't have to wait for the full download of the data or whatever. It's very, very easy to retrieve your data that has been already pre-processed. And for instance, German is around 20 gigabytes, 22 gigabytes. Plus the reprocessing. You don't want to have the up and down all the time, so you want to cache it, cache the results. You could do the same on the right side for the output models, but might not make sense. It's up to you, okay? But this one I would highly suggest to cache it. That's pretty much it works. If you don't run the job after a certain amount of time, the cache is gonna expire and the data is gonna be kind of lost forever. Not really lost, because in fact it's been synced up at some point. So you just lose the cache. Okay. So let's do this type of things. But before moving to that, you need to know that some libraries like HuggingFace are writing without telling you. Unfortunately, even if I love the guys from HuggingFace, it's writing to a hidden directory, which is .cache. And this .cache is used for many stuff, but especially for downloading data. So if you download a zip before, for instance, for the dataset, so the dataset library from HuggingFace, I guess, is writing to the .cache, unfortunately. And because, for instance, German is 20 gigabytes and you have 16 gigabytes on the machine, it's not gonna fit. And while downloading the data or pre-processing it, it's gonna rise. The user is gonna rise, and at one point it's gonna crash because you won't have space left on device. So the job's gonna crash by itself. So what I would do to make it kind of a quick workaround, because we didn't thought about that to be fully transparent, and we're gonna implement something to do this in the future, to fix this in the future. So those type of use cases, it's gonna create the bucket. So either you create a bucket that's called cache, or it's gonna create on the fly. Okay, and so you're just gonna create a bucket that is called cache, and you don't put anything in there. We don't care. What we're gonna do, we're gonna create a workspace .cache, okay, which is, so this one in fact is up, this one is this, and this one is this, okay, and all of them will be attached to the GPU. Okay, the point is, like, I don't want to think up and down about this cache. I don't really care. Okay, so what I would do is I would attach this /workspace cache to a random or dummy object storage bucket, and before killing the job or at the end of the training, I would just rm rf /workspace /cache everything. I would do that, so it's gonna sync up something that is empty. You're not forced to do it. Like, you can just don't do the rmrf at the end of your script. It's up to you, but I would kind of suggest to do it. Otherwise, it's gonna sync up all the cache and you don't really care about it. Just in case, we're gonna cache it just in case you forget the rmrf cache. Otherwise, it's gonna download everything all the time. It's gonna be a pain. Okay, this is the schema. It's very simple, in fact. So OVH AI job run. What I'm gonna run a job with GPU. I'm gonna have one GPU running. Okay, I want to have a volume, the data volume there, and I'm gonna do Italian, for instance. Okay, or Turkish. Turkish is the default model, but I can take Turkish. Okay, so data, it's based in the data center, the Gravelin data center, and I want the subdirectory Turkish. I'm gonna say, okay, you're gonna map that to the /workspace /data Turkish in a read and write way. So I'm allowed to read and write, and I want to cache it. As I said, I want to keep it at the end of the run. Let's make it Italian. It's better. Okay, because that's what I have on the schema. Sorry, guys. The second thing I'm gonna do, I'm gonna attach this cache. Okay, so I'm gonna say volume cache at Gravelin I don't care about the subdirectory because it's a dummy stuff. I'm gonna say /workspace /data /workspace /cache. I'm gonna say it's a read and write mode because I want to write on it, and I'm gonna say just cache just in case you forgot to sync. Volume. So the volume, the third one there is gonna be output models. Okay, so I'm gonna say output models. It's gonna be in Gravelin, this bucket also. It's gonna be linked to the /workspace /output output models /Italian. Is gonna be a read and write system, and it's up to you if you want to cache it or not. I won't cache it. I don't need to cache it. Okay. Okay. So what's next? I could add some extra environment variable, but in fact I don't really need it. I would just edit the Jupyter notebook. So I'm gonna run this. As you have seen, I've put some subfolders. Subfolders will avoid and the system to synchronize the full bucket. Otherwise, it's gonna synchronize the root folder, and it can be pretty long if you do multiple experiments. So limit that to the experiment you're running. It's better this way. So it's gonna optimize the time of the spawn of the job, and at the end of the job, the time of synchronization up for the data or for the output model. So it's way better this way. You're gonna save time in your experiments. Let's go. So the job is running. I'm gonna have what we call containers, so data containers. This one is data based in Gravelin with the what we call prefix is the subdirectory. It's gonna be mounted in this path in the container, the Docker file, Docker job. It's gonna have a read and write permission. It's gonna be cached, etc., etc. So you see, we have all of this stuff, and we have the status. And what I can do OVH AI job list, and see the job is initializing. It means that it's starting. There are many status. The first one is in initialization, and initialization can take long. The first thing is like it can take time to pull the Docker. So if you build a custom Docker image that is like 80 gigabytes, of course it's going to take time to do the pull. That's the first reason it can take time. The second reason is like you can have a pretty big bucket, object storage bucket, and it's going to take time to bring it back to the NFS. So that might be the reason. What we're going to do, we're going to say OVH AI job get. I'm going to put the ID there, and I'm going to have the status, and you say, wow, okay, it's pretty cool. I see the transfer is, whoops, sorry. There is a bit of, it's supposed to be the opposite, but whatever. You see that the status is kind of transferring some data. I already trained the Italian model. That's why I have some data coming. The cache is empty, so okay, I don't care. The data, I already have the Italian data, so it's not bad in the end. I didn't cache it before, but it means that I won't have to do the reprocessing. So it's pretty cool. It's going to find back the data I've already done in over experiment. And you see output models, I already have 14 gigabytes data for the output models with all my logs, etc. So it's going to take a bit of time to spawn. See, it's moving around to get this time of initialization. So I didn't activate the cache before for the output models and data, and as you can see, it's going to take time. If I have in the past, in my previous job, added the cache option to this, like we did there. If I added that in the previous job, it would have taken like 5 minutes, like it's doing right now. It would have been like very, very, very fast. It might have already been spawned. So you see, the purpose of the cache is just to check the integrity of the data and implement the difference, and boom, you're gone. So that's it for the first video. I'm gonna show you, sorry, a job running. I already have a job running, by the way. It's the German one. And basically German, as I said, is 20 gigabytes. oops, sorry, it's this one. It's 20 gigabytes, the German one. I did the fine tune, and this one was kind of crashing because it was too big and it was writing into the let me show you. It was running in the dot cache there, and you have a HuggingFace, and you have dataset, and you have the download, and then you have all those files. And this is where it was downloading a part of the data and make it kind of big. So I'm gonna move there. Anyway, it was in this directory making stuff a bit weird and taking a lot of space. So I don't remember exactly. I don't remember exactly where it was. Oh, maybe this one. Okay, I don't know. But anyway, it was downloading there, and it was taking like a lot of space, and this is why some of the jobs of the participant were failing. It's because of that. So thanks to the system we have and the cache and the data system, you can have an infinite size of data set and to run on. So it's pretty interesting, and the speed between the network storage and the GPU by itself is very efficient. So don't worry about that. Another thing I wanted to share with you is the way to monitor your job, the help for the monitor, and especially you can check where the job is failing if you face a job failing. So if I take a job, for instance, this one, I'm going to say OVH AI job list -h. Sorry. Okay, there. And you see there is a way to see more information about the job by using the F function, the fields. So I'm going to take the fields. I'm going to get the ID of the job, of course. I'm interested into it. I'm maybe interested in the job URL, the image that was used, the state, the age, and the monitoring URL. Monitoring URL. I'm gonna run that. I'm gonna make it a bit smaller. Whoop, whoop, whoop. Here we go. And I have, you see, a monitoring URL there. So I can check my job, access it, but also I can access the monitoring URL. So what I'm gonna do, I'm gonna click on it. It's gonna open the Grafana, and you're gonna see the network usage, etc., the CPU, the GPU, and all those things. And it's pretty much downloading right now. This job has been downloading for quite some time, the big data set. But what was causing the crashes for some people was that this cache /workspace/cache, if you remember there, this part was on the ephemeral storage and was growing up till it reaches the limit that is 16 gigabytes, and then no space left on the device and the machine was shutting down. So this is something that we're going to work on, but we did not expect this type of dataset to be 20 gigabytes stored on hidden cache folder. So guys, now you have all you need to monitor your jobs and to improve your training and have fun. Okay, that's it for today for this video about the infrastructure. I'm gonna have two other videos, one talking about the Jupyter notebook I've added, just a quick teasing on that. I took the one from Google Colab, I updated it, and it's now you have the 1DB support, etc. And I'm gonna show you how to use 1DB, and I'm gonna have another video about how to manage your data, upload it, download it. See you. Don't hesitate to comment under the video if you have any question. If you like the video, share it with your friends to help them learn to train Wav2Vec. If you like the video, thumbs up and share the video and subscribe to the channel. See you.